Hello students, welcome back. The final section, section 6, is actually an important section for STEM algebra. For us, it could be a bit too deep, so I kept it as an optional section, but we may need some of it, or maybe all of it, when we deal with quadratic functions or later. So it may be a good idea to study this. Still, for now, I'm going to keep these as an optional video. Okay, here we go. Transformation. And if you have a graph of y equals f of x, and replacing x by x minus c, we can shift the graph by c in x direction. If you have y equals to f of x, replacing y by y minus c, we can shift the graph by c units in y direction. So if you want plus c, go backward, minus c. In that particular direction, plus c in x direction, x minus c. Plus c in y direction, y minus c. Inverse operation. Kind of like this. Y equals to f of x is this blue graph, then y equals to f of x minus 2 is this red graph. Do you see? Horizontal shifting by c in the x direction. And here, x plus 1.5, so actually minus of negative 1.5. So negative 1.5 in the x direction. So actually it's going left. So blue graph the original, and then it is shifted to the left. Left by 1.5 units. Same as negative 1.5 units in the x direction. Here's another example. Y minus 1 is f of x. That's a red graph. So shifted this blue graph by 1 unit upward. And then some simplification is in order. Flip this minus 1 to the other side, and you get y equals to f of x plus 1. And that's this red. And then you can shift down as well, y plus 2. So I'm shifting 2 units. Actually, y plus 2, so minus of negative 2. So I'm shifting negative 2 units in y direction. In other words, 2 units down. Flip this plus 2 to the other side, we get f of x minus 2, by the way. Okay, so much for shifting graph. Now let's consider stretching graph. I want expansion in x direction. Stretch by factor of c. Double it, triple it. Remember, inverse operation. We go backward. Divide by c. Same thing goes to y. Divide by c. Here we go. Original graph, y equals to f of x, and double it. And then we get the red graph. And if you're going to double it, you go backward, divide by 2. Here, blue, and then we shrunk it. We compressed this blue in x direction to make it into red by a factor of 3. So compression. So we have to go backward. Instead of reducing into 1/3, inverse operation, so multiply by 3. And then the same thing in y direction. Doubling, so stretching in vertical direction. So y divided by 2, you see, inverse operation. And then flip this 2 to the other side, we get this expression in the end. And how about this? This blue is original. And then I want to compress now vertically and make it 1/3. So you have to go backward, inverse operation. So 3y, and simplification yields y equals 1/3 f of x, like this. So again, we are doing inverse operation. We wanted to add c, then we do opposite, x minus c. if you want to shift by C unit, we go backward, minus C. Same thing. If you want to stretch by C, we divide in that appropriate direction. Flipping graph in the x direction horizontally, then x becoming minus x. Flipping in y direction vertically, then y becomes minus y. Kind of like this. Blue graph, flip it over, we get red graph. Remember, x became minus x. It's a little bit harder to see, but blue graph became red graph by flipping over. X became negative x. And then this time y becoming negative y. This is original blue. And then y became negative y. And then flip this negative to the other side, so y equals to negative f of x, and that's this red graph. It's easy to see, top became bottom. This one is a little bit harder to see, but you can clearly still see this blue flip over and becoming red. Let's see, shall we do some translation? Okay, this is a kind of example that we'll have to do in quadratic function part in order to get the so-called standard form. And that's something we are going to do, let's see, in week 7, maybe week 8, I'm not so sure, a little bit later. But it's not going to hurt. We have some head start. So if you use your grapher, if you use technology to graph y equals x squared, you're going to get this kind of graph, blue graph. And the same graph shifted to the right by 2 units. That is 2 units in x direction. We do inverse operation, x minus 2. So we get that, right? And then from here, let's see, we want to compress this thing vertically into something like this by factor of 3. So we're going to compress by factor of 3, and then y coordinate will become 1/3 of original. Then replace y by 3y. So 3y equals to, so y equals to x minus 2 squared. From here, 3y equals to x minus 2 squared. So from red to purple. So that's what's taking place from here to there. Okay, I'm compressing vertically, so y coordinate is becoming 1/3 of the original. And then you have to express this into explicit y equals f of x form, and that's why this is becoming y equals 1/3 x minus 2 squared, and that's this one. As a matter of fact, from red to purple, that's graph transformation, and this one here is not really a graph transformation, it is just algebraic manipulation, flipping this 3 to the other side so that we get ready for the next transformation. So we get purple, this one, and then I'm gonna push it down a little bit, so shift it by -1 unit in y direction, so shift it up by -1 unit, or shift down by 1 unit. And that's, as a matter of fact, y equals 1/3 x minus 2 squared. That's what we had before. But you see, I'm going -1 units in y direction. That is 1 unit down. So we do inverse operation. Negative of -1, which is plus 1. And that is the final brown graph. this one here. And then of course we want to express it in explicit form, y equals f of x form. So flipping this one to the other side, we get the final expression there. And that is the expression you want in the end. So from here, shifting the original horizontally by 2, stretching vertically by 1/3, which means compressing, and shifting vertically by -1, or 1 units down. And what do we have? In the end, we get this kind of graph transformation through these processes. In the end, what do we have? We have y equals a times x minus h squared plus k form. And then a is associated to the shape of this parabola, this 1/3, from the original shape, vertically compressed by factor of 3, factor of 1/3. And also another aspect is the vertex here, 0, 0 is moved, shifted 2 unit, so 2, and then 1 unit down, so we get 2, -1. Those are h and k values. This thing is called the standard form for quadratic function, and we're going to study this in detail in, let me see, lesson 7 or lesson 8, something like that. Do you have another example? No, not this one. This one is a bit too advanced. We are doing rational functions. Let's see, do we need to know the general case? Oh no, not really. That's getting a bit too deep. So that's how we deal with transformation, and then we restrict ourselves mainly toward the application to quadratic functions that we are going to study a bit later. Still, if you had difficulty following this idea, graph transformation, feel free to just give up, because after all we are doing 1324 business algebra, not the rigorous STEM algebra. So it's okay to cut some corners here and there, and this is one of the casualty there. Let's go back into gray, because after all this was originally intended as an optional section, and this video of course is an optional video. Okay, that completes lesson 3. We'll meet again next week in lesson 4.